is Mark Keene. I'm here to show you the largest production dredge that we currently make. It's called the 8195. Actually, this particular one, we can also call it 8116 because it is powered off a 116 horsepower Deutz diesel engine. This is a very popular model because it is just a monster powerhouse. We put a much larger engine, we run dual pumps on it, and this machine is capable of handling like 120 feet of suction hose. It's really built for extreme conditions. But a lot of my customers like it because they want to move a lot more material. Since you're pushing so much power through the power jet, you have so much strong vacuum, it just pulls sand from like 3, 4, 5, 6 feet away. It's just an animal when it comes to suction. Another reason people like it is it has a very large and wide deck. You'll notice that the deck is extremely large and has big outrigger pontoons on the sides, and that's all to accommodate the extra weight of the engine and the extra weight of the foot valves and pressure hose. But what happens when you have this kind of power, when you throttle the dredge up, it's like a car. When you give the machine gas, it wants to go but it leans to one side and then it kind of levels out. But it has so much pull on this side of the dredge, it's not even funny. So we have to put the pontoons quite a ways out there to help keep the machine balanced. All right, this is another view of the larger engine and pump package. Again, it's a 6-cylinder, 116 horsepower Deutz diesel engine, and we are driving 2 of our P1500 pumps, which produce about 1,500 gallons a minute open flow, and probably actually in a working load condition with the restrictions, probably close to 1,000 gallons per pump. So we're actually producing about 2,000 gallons a minute flowing into the power jet itself. All right, this gives you another perspective on the dredge. You'll notice that we have a really long, wide sluice box. The sluice box is approximately 30 inches wide and about 20 inches long. It's a fairly simple design that we've had for quite some time, probably close to 15 to 20 years, because it's a very successful design. The first section of the sluice box, like the first 3 sections, which are broken up into 4-footers, that's all dedicated to fine gold. The last 8 feet of the box is typically set up to recover gemstones and diamonds or any other kind of medium to heavy weight material. You'll notice that our overall width of the dredge is approximately 8 foot for this rear section back here, and on the upper section of the dredge, because of the larger engine to support it, we have outriggers, and I believe we're about 14 feet wide. And that gives, again, the dredge a lot of stability. All right, on this side of the dredge, you can see we have the 2 air compressors that we're driving, and we have our decks that are in place too, so you don't fall through the machine. All right, for those of you who don't really know how a gold dredge works, I'm going to kind of walk through the basic system of how it works and what makes it work. Obviously, the heart of any dredge is going to be your motor and pump package. And this one, again, is just an extreme package. So basically, to get your machine going, you have what's called you have to prime your pump. And in order to prime your pump, you have a foot valve. Now, a foot valve is really nothing more than there's a big check valve. If you look down the center here, you can see a big rubber flap. And what happens is when you pour water in here, the water stays. So this is attached, this device here is attached to the bottom of this pipe right here. Of course, it has to go deeper in the water, so I can't really set it up. And to prime the pump, and what priming means is we have the entire motor and pump, we have both pumps completely flooded to the top full of water. So it's a fairly simple system. This is nothing more than a sealed radiator cap, and we'll take, let's say, a 5-gallon bucket, and we'll pour a bucket, maybe a bucket and a half of water until the water overflows, and we'll fill this up, and we'll put the cap on, okay? And then we'll come over to the next pump, all right? And we'll take this cap off, pour a couple 5-gallon buckets of water down the throat until it overflows. And again, we're filling up our foot valve. It's filling the water all the way up to here, so I know the water's full right up to the top of the pump. And once that is all fully primed, then I can start my engine. So let's just say I've started my engine. So you have high pressure water which is coming down both of these 4-inch pressure hoses. Now you're probably pushing somewhere between, in real numbers, probably 800 to 1,000 gallons a minute per pressure hose. As we go down the pressure hose, we install a really nice, efficient splitter system. Okay, now a splitter gives you a nice split so you have even a nice sharp edge inside, so that you don't have a lot of turbulence or you don't have a lot of sharp bends. And it splits it off into 2 3-inch pressure hoses. Now, we're probably producing somewhere between 400 to 500 gallons a minute per pressure hose. Now, what's nice about these, they're all set up with cam lock releases. We use really high quality clamps, and to take your pressure hoses on and off, you just release your cam. Okay, nothing's ever easy, especially when it's new, everything's tight. And to reassemble, you just push these back on, close your ears at the same time, and you're ready to go. Now, the high pressure water is going into here, into the power jet. So I'll show you what the power jet looks like. Okay. Now, this is a power jet. This is the part that actually creates the vacuum. Most power jets have 1 or usually 2 inputs. Okay, and usually we would have, for like a standard 8-inch dredge, we would have an input here and an input here. This one happens to be a quad jet, or 4 eductors. So what happens is, once the water goes inside the power jet, or inside the jet logs in this device here, there's a reduction inside here, and it's actually quite a science to get that, the reduction and the shape of the water to enter into the jet correctly. So what happens is, if this is your power jet here, you have the high pressure water coming in, squirting into the power jet at multiple positions. Okay, what happens, it creates velocity in the tube, and this velocity creates a vacuum on the suction hose. Now, there's a lot of formulas and stuff you can go by, but typically on a shorter piece of hose, you'll have anywhere from like a 0.75 to a 1-to-1 ratio of water going in, as opposed to what you're pushing in. So we're capable of pushing close to 2,000 gallons a minute. So you can imagine the amount of water we're pulling through an 8-inch hose. It actually has so much suction, there's no way you could ever handle it. But the water coming in through here, through the pressure hoses, and all the water jets intersect a little further up the line here. And then once the water goes through the power jet, it goes into what's called as a jet flow, or it's almost like an expansion chamber. So what happens, the water's traveling up the power jet, and it's picking all that material and water behind it, and then it goes into the jet flare. And when it goes into the jet flare is a place for the water, to use the final energy of the individual water jets going in, and it also slows the material down. So the jet flare slows the material down as it travels up the tube, and actually the heavy material will settle towards the bottom of the jet flare. And I'll give you a better perspective from that in a few minutes. Now, this is what you call a suction hose quick coupler. Okay, so what happens is this has a big cam lock on it. And what you would do is you would slide a piece of 8-inch hose inside the cam lock. Okay, and then once you slide the hose in, you then take this and you would close your lever, and it actually takes that and squeezes around the outside of the 8-inch hose, and it locks it into place. The reason we do that is we actually are trying to maintain a larger ID inside the power jet. The power jet here is probably roughly about 9 inches inside. And again, we do that to reduce the chance or hopefully limit any rock jams that you would normally get in a system like this. Now, we're going to assume we have, let's say, 40 feet of suction hose, okay? And then this is called an 8-inch swivel tip with a suction breaking flap. This is typically what is attached to the end of your suction hose, and you would have your 8-inch hose sliding up to about right here, and you'd have a hose clamp. Now, it's called a swivel tip. Again, very simple. This rear joint rotates. Okay. To wrestle an 8-inch hose it's fairly soft, flexible hose. You can bend it around, but you can't really twist it. It's like trying to mess with an anaconda. So this allows you a lot more mobility. And also, we have what's called as a suction breaking flap, and I'll explain that in just a moment. But there's so much power, there's so much vacuum on this ring that if you get a rock and it goes BAM and it locks onto here, most people, especially with this particular model, don't have the physical strength to remove the rock. So what we have to do is we have equipped it with a suction braking flap. Now the vacuum's going to hold that locked on position. It's not going to fall off on you. But what happens when you get a rock stuck on that, rather than have to wrestle pulling a rock off, you just take this flap and you'll peel off just like this. And then the water will get sucked through here, then the vacuum will be diminished on the suction tip, and you can pull the rocks off. So it's pretty simple. When you're down dredging, you're going to be wrestling this thing, sometimes riding it like this, sometimes pulling it along like this. But when you get a rock that sticks on the tip, you pull it back, take the rock off, and then you can go back to work. Okay, this is just another view of where the power jet attaches to the jet flare. You'll notice there's a locking lever right here, the same as locking in the suction hose. So you can see how the jet flare is about probably 8 feet long, and it gets wider and wider towards the discharge when it enters into the sluice box. And what that basically accomplishes is it slows the material down. And it also allows the material to kind of zone out. In other words, the heaviest material will slide up the bottom of the jet flare, and the lightest material will slide up through the top of the jet flare. So you've already got your gold and your heavies going up through the bottom.
Action.
One other major upgrade on this dredge is we actually equip it with 2 of our big 263 air compressors. Typically, one of these compressors is more than adequate for even an 8-inch dredge. It'll carry multiple divers. But again, we're not talking about a typical dredge. We're talking about an extreme piece of equipment, extreme power, extreme depth. So we actually overkill the air compressor system. It's even more important in this machine than any machine that your divers are all certified divers and know what they're doing, because all the dangers you have with scuba are identical to hookah system. So you really have to know what you're doing, especially when a machine like this you have greater depth capability. It just means you have greater danger capabilities too. But we do a lot of little things to ensure the maximum safety. Again, it's an overkill compressor system, almost twice what you would need. And then we typically plumb the 2 compressors into a large, let's say a 9-gallon stainless steel reserve tank. And then we have our multiple divers hooked up to it. You can have 2, 3, 4 divers that you want. Typically, you only want to run about 2 divers. You have one man is a rock man who's going to be moving the rocks and the trees and the cobbles out of the way, and the other man's going to be working with the swivel tip, and he's your hose man. And the rock man's there to assist the hose man all the time. So also we have on these compressors, we have a pressure relief valve. Now typically these are adjustable, but I set mine typically to about 50 to 80 psi depending on what depth I'm going to. But we put them on the end of these hoses, and then we actually slide a clear piece of hose over this and we run it underwater. And that's because these can be obnoxiously noisy. You'll hear this like but really, really loud. It gets irritating. It almost overcomes the noise of the engine. So that's what these are for. Now, back to the safety issues, we do a remote air intake system. So we have actually 4 air intakes on the unit, and then we plumb all this air hose along down the dredge, and we attach to the far end of the dredge. And you'll notice we have 4 air intakes. And it's a fairly simple theory. You only want to keep the air intakes as far away from the engine as possible, because you don't want to suck exhaust fumes. So this keeps you from sucking in carbon monoxide or unburned diesel fuel or whatever. So it's very important to plumb your exhaust. And the bigger the engine, the greater the horsepower, it becomes more important to separate the 2 even further, because you have higher volumes of exhaust. So that's what all this stuff is for. All right, one more important point with a sluice box of this size is it does require quite a bit of an angle. Now, there's a lot of theories to what angle you run your sluice box at, but I typically say about 1 inch per foot on a big dredge like this. So that means if you have a 20-foot long sluice box, you're going to have probably close to a 20-foot drop on a sluice. So it's fairly easy to adjust the sluice box. You just have it, crank it up, okay, and then you reset your chain links, and you crank it a little bit beyond the point you want to. Then you set your chain link, and then you actually back the wing down a little bit. So you don't really want to keep your load on your cables, because you never know if a cable is going to slip or break or whatever. So if you keep it on your chain links, you're probably better off. But again, we'll say a starting point is about a 20-inch drop. In some conditions, you're going to run the sluice box flatter. In some conditions, you're going to run it steeper. every area you go to has like a different kind of requirement. That's really a hard thing to tell you what it is. You just have to get out there and run it and test the machine and see how you want to position it, what works best for your conditions. The nice thing about these big 6-cylinder diesel engines, besides being really smooth, is that you've got a Murphy panel, okay? And a Murphy panel basically has an auto shutdown in case the engine gets too hot or something starts to fail on it, so you're not going to destroy your engine. And it's a pretty nice setup. You've got basically, it looks like an oil pressure gauge, an oil temperature gauge, and a RPM gauge and an hour gauge. And it's important to document all those things. You also have on the engine, you have a nice throttle control here. Okay, you can probably see it going back and forth. I find that most of my customers run the engine probably around 13 to 1500 RPM because we're all trying to conserve diesel and so on. But speaking of conserving diesel, this is a 10-gallon fuel tank. You have a petcock on the bottom, an on-off valve, and then you have two hoses. One hose goes to the back of the, I believe that's your fuel pump, and then you have, this is your input. In fact, that's a primer to prime the fuel system. So, but this line is a return line. All right, since we're talking about the jet flare, I'm going to show you what it looks on the discharge side of the jet flare. By the way, you notice we have a really thick, very heavy rubber mat, and what this is for is it helps slow the material come out of the jet flare. It spreads the material out in the sluice box, and it also breaks the water tension. So if there's any bubbles or turbulence, it knocks it all down and it smooths out the water. But anyway, let's continue on. You can see the discharge of the jet flare. Again, it's a very wide, and it's probably about I don't know, maybe 24 inches wide, something like that. I'm not sure, but you'll find the heaviest material sliding at the bottom of the jet flare and the lighter material up here. But it's all about utilizing the energy in the power jet to its optimal efficiency, and it's about slowing everything down, so it's really a nice working system. So I'll put the flap down. Well, actually, I'll show you since I'm right here. Again, this first section of the dredge is what you call as a 3-stage sluice box, and it's fairly simple. The first section in here is really for your coarse gold or your nuggets and that type of thing. So most of the time, or probably 99% of the time, you find all your big gold in this first section. And then the next section you have in the sluice box kind of falls into your 3-stage. So I would call that first riffle your first stage. I would call this second upper riffle here would be your second stage, and the lower riffle would be your third stage. Now I'll show you a quick look at this like underneath the screen. Now this first 8 feet of sluice box, or I should say this section and the next section, this is about 8 feet. There's actually 2 layers of a sluice. So I'm going to lift this clasp. You can look down in here. You can actually see you have a layer of green rib carpet, a layer of miner's moss, a layer of expanded metal, and a riffle on top. And you'll probably find 90% of your fine gold be trapped in this lower riffle board. The nice thing about it is that you're only going to have your small material in there, so you really have a fantastic opportunity to capture all your fine gold. Since you don't have a lot of larger rocks interfering with the natural riffle action, you really get some fantastic fine gold, and that's what you call a 3-stage. And again, that section covers about 8 feet of box, so you got quite a bit of recovery system in there. And I'll just put this back into place. Shoves back in there, and then once you get it lined up, just latch it down. And we do use nice quality latches. Now, if we travel down the box a little further, you'll see we have a couple different size riffles. We have short riffles, tall riffles. Now these are typically classified as like a Hungarian riffle, okay? And the nice thing about these is they're what you call as a regenerative riffle. In other words, let's say if they are saturated with black sand and other light material and heavy material, it will continually keep the black sand in a state of agitation so the gold can get to the back, and can actually drop into it. So it's a very fluid bed. So you can take your fingers, you can actually run your fingers in the riffles. It's not hard packed, it's relatively soft material. But we use different size riffles to work in different types of conditions. This one may work in a higher flow of water, this one may work in a lower flow of water, so we try to give you a variety of conditions. We do make a lot of custom boxes for certain areas, but it depends on the area to what riffle is going to work best for you. And we're constantly changing and improving and making some changes on things. Now, if we come down to the center of the box down here, this riffle design is called this is more of a diamond riffle, okay? It's a big, tall, deep riffle. And it's designed to capture that medium weight of material. See, your black sand's very heavy, your gold is very heavy. You have a specific gravity. The black sand can be around 5 to 6, the gold is around 19, but when you start going for diamonds and other gemstones, those are real light, those are like 3 to 5. So what we do is we build a relatively large riffle. We capture a lot of gravel, but when you start getting into the good gravel, you have to suck the riffles clean. You don't want to shut the machine down. You continue to run the machine while you're cleaning this out, but I'll cover that a little later. To the diesel tank. Very important that I can't emphasize enough. There's really two things you can mess up a diesel engine with. First of all, it is absolutely essential that when you replace your oil, you buy the best oil you can. Buying the cheap local oil in Africa is no good. You should either take your oil over with you or buy the best oil available in Africa, even if it costs you more money. Because oil is not just the lubrication, it's also the cooling system for these larger diesel engines. So, very, very important to understand that. The second, but just as important thing, it is so critical that you have good, clean diesel fuel. Typically, we will provide you with or sell you a secondary filter that goes onto here, okay? And when you pour your diesel fuel into it, it's both a water and a particulate filter. If you do that, you'll probably never have any problems with it. But what happens, the local guys who are running the dredge, they get lazy sometimes, and they don't maintain the oil filters, and they especially don't maintain their fuel filters. Dirty fuel will destroy an engine. Here you have probably like a $15,000, $20,000 diesel engine, and I see people blow them up all the time because they get lazy and they allow water to get into the diesel engine. Water and diesel don't mix well. You start blowing up injector pumps, you start blowing up injectors. So when I tell you, maintain your engine oil, maintain the quality of your diesel fuel, it is probably the one most important thing on the whole dredge you have to understand. Just a couple quick notes on the maintenance of the pumps. There's very little maintenance. The main thing is do not let the pumps run dry. Do not have the pump completely primed before you start your engine. A lot of guys get out there and they'll start it and you run the pumps dry, you can blow a set of pump seals. And they're repairable, but who wants to deal with headaches? Also, the pumps have a Zerk fitting on them. Both pumps do. And you maybe want to grease them maybe once a week, but you only want to do it on a warm day when the pumps are good and hot. So what you do is you come in, you just put hook up your grease connection, pump a teeny bit of grease, maybe even like a half a pump, and that's all you do. If you feel any pressure, stop. Because if you over pump grease into the bearings, you blow the bearing caps off. To make a long story short, you got two big bearings in each pump. And we remove the inner bearing caps. So we have a lot of grease that goes into the two bearings. But if you over grease the bearings, you blow the cap out and you have nothing to hold the grease. So remember to grease it once in a while, but don't overdo it, and it's best to do it on like a warm day, even when the pumps are warm. That'll reduce the chance of maybe blowing the bearing seals out. And again, don't run it dry. All right, this particular dredge is equipped with a 4 by 1.5 inch splitter. And what this does, it gives you a very efficient way to put water pressure into the secondary hose. We do it in this kind of a fancy way, but that's so you can achieve both static pressure and velocity. If you just kept it coming off, you'd only have static pressure, but we need both. You need a lot of flow. So basically, this is an 1.5 inch pressure hose, and it can be used for a multitude of applications. You can use it for taking it down, have like a firefighting nozzle on the bottom with the divers where they can blast cracks and crevices clean. And this is basically your control knob for it. we use both here and here what's called as a high flow ball valve. And the differences between a standard ball valve and a high flow is that they have a larger ID, so you create little to no restriction when you put these in the system. Now, in case you need more water pressure for this 1.5-inch hose, we actually equip this one with a large 4-inch ball valve, okay? Not cheap, but they really come in handy because you can get absolute full pressure to this hose. And another application, or the more common application that we actually use these for, I'll show you down at the other end of the dredge. All right, now that we have our 1.5-inch hose connected over here, we have a small 2.5-inch suction nozzle. What I'm going to do here is let's pretend we're dredging right now, and I have sand and gravel and water coming down the sluice box, and we're in like let's say a diamond area. To make these large, tall, deep riffles work efficiently, you have to keep them relatively clean. So what I'm going to do is about every hour or so, I'm going to open up my ball valve that I just showed you. I'm going to take my nozzle, and I'm actually going to take it and just drop it into the riffles, and I'm going to just vacuum out the material. And you do this while the dredge is running. You don't shut the machine down. See, it's so important to keep the machine running all day long, like for 10 hours straight, and never stop, because you want to get the maximum amount of material so you have the maximum amount of efficiency. So that's why we do it actually while we're actually running the dredge. So while the machine's running and I have divers down sucking the material, I'm going to come in here periodically every hour to 3 hours, depending on the kind of material that I'm in, will determine the span of duration between cleanups. But I'm going to suck the material out of the riffles, and then what's going to happen is the material travels up the 2.5-inch hose, and typically we'll dump the material into a small wash tub, a metal bucket, whatever you want. A lot of guys just pump it directly into like a small rice bag, okay? And the small rice bag just drains the water out, and what they'll do is they'll actually take those bags of the concentrate that comes out of here, and they'll actually stockpile the bags on their deck of the dredge. And then periodically, every couple hours or 4 hours, whenever you do a shift change on your divers, we'll take all those bags of your material that comes out of this lower riffle section, and they'll take it to a tender boat, and they'll transport it to shore for a further separation. In regards to cleaning up the sluice box, typically I like to clean my sluice box at least once a day. Sometimes if I'm in a lot of good gold, I'll actually take that first section of riffle I showed you, the nugget catch, and clean that up because I want to pull my big nuggets out, because you don't want other people to be picking through your sluice box, pulling out the nuggets, and I've had it happen to me. So, again, cleaning this up, it depends on the kind of material. It can be anywhere from 1 to 3 hours to clean up your main sluice, usually once a day. But you shouldn't go more than a day or two, more than 1 day, because there's some weird things that happen when you start the dredge up the next day. I've seen it actually kick some gold out. So I like to clean up my sluice at the end of each day. If you look here towards the end of the sluice box, I've actually equipped it with a sump system. And what a sump system is that all the material that travels down the sluice box, remember, it's slowly separating by weight. So the heaviest stuff is coming down the bottom of the sluice, and the lighter stuff is coming up towards the surface. So all the heavy material is settled out by the end of the sluice box, and then it falls through the, let's say, 3/8 woven wire classifier screen. It falls through the screen, and it slides down into a sump system. And the sump is nothing more than a large tank at the end where all the material is channeled into one single location so we can suck it up. So I'm going to open up the screen and show you what it looks like inside. Back a little bit, flip it up. So if you look down in here, you'll see that it's open in the front. That's kind of like what you call almost like a slick flip. It allows the material to slow down and slide with very little effort, allowing more material to fall through the woven wire. In some testing, we found that let's just say the material is traveling, my speed references may be wrong, but let's say if it's traveling at 10 feet per second here, well, the water underneath the woven wire is traveling more like half speed, maybe 5 feet per second. So that material slides down through the bottom of the sluice into the sump, and everything gets sucked in through here, and currently we have a 4-inch opening. So the material that we suck out of here is either pumped to shore, and it may be pumped into a jig or another type of sluice box design, or we may even pump the material back up on board the dredge and run it through a secondary sluice that's actually on top of the dredge. But it's a very simple mechanism, but it works quite well. In fact, we've been using the same technology for well over 30 years. In fact, I used to build machines around this design, but back in those days, everybody wanted things a little bit simpler. Nowadays, people are willing to go through a little functionality to get things to work properly. So that's your sump. Just one more new thing that we're working on that goes in this dredge. If a guy is concerned with more just fine gold, we will remove these two diamond riffles in the back and a large expanded metal, very heavy expanded metal. And we have, again, we'll place a large piece of woven wire classifier screen about an inch or two above it. And again, it really helps with the fine gold material, because anytime you can take and you can classify the material before it goes into a riffle board, you get really super enhanced fine gold recovery. And it's real simple. If you have a riffle like this and you have a rock traveling over it, well, if a rock lands here momentarily, it alters the back eddy or the vortex of the riffle. So we put a screen over it and you have a nice even flow. One thing that the average guy doesn't know about Keene Engineering is that we put a tremendous amount of energy in research and development. We use computer-aided technology, hydrodynamics, flow dynamics, airflow control. We do so much work, the average guy has no clue how much really work goes behind the scenes. I've got an amazing engineering staff. I got my brother Patrick, who has got an amazing nose for gold, and he's a great engineer. He helped me figure everything out. I got several other people here who helped me with all the technology. So we're very blessed, very fortunate to have all these resources. And as of late, we've purchased a lot of equipment that really helps with turning a simple idea into a product very quickly.